Welcome all, one and all. This is the fourth video on complex number, starting from problem number 22. This is very urgent and important problem. If a plus ib by c plus id is equal to p plus iq, prove that this and this, the two facts to be proved. Knowing all these four facts, after that this is p plus iq written already. Now taking conjugate, if you are taking conjugate, p plus iq becomes p minus iq, the mid sign is changed. Again plus becomes minus, plus becomes minus. So this is the first part proved. Simply by taking conjugate, the first part is ready. Now multiply a and b. Let it be denoted by equation a and b. So this into this is equal to this into this. After that a plus b into a minus b, everywhere a plus b into a minus b, a square minus b square, a square minus b square, a square minus b square. Now I square is equal to minus 1. So I square minus 1, so everywhere it becomes plus. So the second part is also proved. Now come to the 23 number problem. This is 23 number problem. If a plus ib is equal to root 1 plus I by 1 minus I, prove that a square plus b square is equal to 1. This is also very important problem. So a plus ib is this. Taking conjugate, everywhere we are getting plus becomes minus, minus becomes plus. Now multiply 1 and 2 as you have done in 22 number problem. So again we are getting this is cancelled with this, and we are getting 1 1 1 1. So I square is equal to minus 1, so the proof is conducted. Now the next question, it may be harder to you. 24 number you can do yourself. Now this is 25 number question. If Z1 is equal to Z2, Zn all are equal to 1, prove that this is very urgent problem of higher order thinking ability. Prove that 1 by Z1 plus 1 by Z2 plus 1 by Zn is equal to Z1 plus Z2 Zn. It has to be proved. The students, while proving this, you must remember one urgent formula. So formula is mod Z square is equal to ZZ bar. So this is the urgent formula property I have discussed. So the first given you can square, put a square to all terms, no harm. So squaring all, we get Z1 square. But this gives Z1 bar according to this definition is equal to Z2 bar is equal to Zn bar barabar 1. Now taking 1 by 1. First of all, I am going to take this. Since Z1 bar is equal to 1. So this implies we need 1 by Z1. According to the need, Z1 bar is equal to 1 by Z1. Again, Z2 bar is also equal to 1. All are equal to 1. So this is, we need 1 by Z2. So Z2 bar is equal to 1 by Z2. 1 by Z2 is ready, 1 by Z1 is ready, and similarly this is the first, second, and similarly take this Zn bar is equal to 1. So this gives Zn bar is equal to 1 by Zn. So 1 by Zn is also ready. Now starting from LHS. LHS is 1 by Z1 plus 1 by Z2 plus 1 by Zn. Now put the values. 1 by Z1 is Z1 bar plus Z2 bar plus Zn bar. Now I have taught the property that Z1 plus Z2 bar is equal to Z1 bar plus Z2 bar. Now bar, all the bar can be composed this. So all are composed. So Z1 plus Z2 plus Zn whole bar. And after that, one more property I have suggested, that Z bar is equal to Z. Modulus of Z bar is equal to modulus of Z. So even if the bar is removed, Z1 plus Z2 plus Zn, so this is proved. RHS. So the proof is conducted. Now it's time to solve the complex number. Solve the equation of complex number or find Z. So just see the equations regarding complex number. You must have done many problems of algebraic equation, but this is complex equation. So solve mod Z plus Z. Mod Z plus Z is equal to 2 plus I. Now let Z is equal to A plus IB. So start, this is mod A plus IB plus Z is A plus IB is equal to 2 plus I. Now you know that the modulus of Z is A square plus B square root. So this is A square plus B square plus A plus IB is equal to 2 plus I. Equate real imaginary part. To solve the complex number you need A and B. So let us see. This is your imaginary part 1. So B is equal to 1. And you get this A square plus B square plus A is equal to 2. This is the real part. This and this are the real part. B is equal to, use B is equal to 1 here. So this is A square plus 1 is equal to 2 minus A. Now we are squaring both sides. So this is A square plus 1 is equal to 4 minus 4A plus A square. This A square cancelled. So we get 4A is equal to 3 and hence A is equal to 3 by 4. A is equal to 3 by 4, B is equal to 1. So your complex equation is solved. Hence solution is Z is equal to A plus IB. Put the value of A 3 by 4 plus 1I. So this is the solution of complex number. In this way you can solve the equation of complex number. In the last problem of exercise 2b, this is the last problem. Find theta. This is 2b example, exercise 2b, fifth number. Find theta if 3 plus 2i sin theta by, this is also very urgent problem, 1 minus 2i sin theta. Find theta if this is purely real. For purely real you have to find out the value of theta. So rationalization is compulsory. So 3 plus 2i sin theta by 1 minus 2 sin theta, 2i sin theta. Again I, so rationalize it. 1 plus 2i sin theta by 1 plus 2i sin theta. Now multiply this 3 plus 6i sin theta plus 2i sin theta and this plus 4i square sin square theta by A plus B into A minus B, A square minus B square, so 2i sin theta whole square. Now this is your 3 and I square is minus 1, you know. So 3 minus 4, this is minus 4 sin square theta plus both are composed 8i sin theta minus 4 sin square theta by 1 plus, due to this I square minus 1, this plus 4 sin square theta. Now this is purely real. Purely real. So imaginary part must be 0. Imaginary part is 0 and this is your imaginary part 8 sin theta. Hence 8 sin theta is 0. So sin theta is equal to 0. Now you have to give the solution of this. Sin theta is equal to 0. Earlier in trigonometric equation I taught you through the video that if sin x is equal to sin alpha, if this, then x is equal to n pi plus minus 1 to the power n alpha, where n is a member of integer. So this becomes sin theta is equal to sin 0. So theta is equal to n pi plus minus 1 to the power n alpha is 0. So this part is 0. Theta is equal to n pi, where n is a member of integer. So this is your final answer. Now it's time to start 2C exercise. In 2C exercise, thank you very much, student. 2C exercise will be discussed later on. Thank you.